Yeah, it's another day that we are continuing with our revision on business data analysis, and today we are going to look at a theory question or a theoretical lesson just to look at a topic of data analysis. So we are going to look at this and data analytics, however we are calling it business data and data analytics, big data and data analytics, and I will be taking you through, and we shall start by defining looking at the definition of some terms. And the first one is a big data, which refers to any large and complex collection of data. If data is so large and very complex, that's what we are calling big data. And that's why when you look at the analytics, we are looking at analyzing that big data, that complex data, so that we can be able to get an informed decision. We can get meaningful interpretation of the data is because the data is complex. So big data, that is complex data or large data. Data analytics, the process of extracting meaningful information from the data. So that particular what we call data mining, we extract the meaningful information from that big data, is what you're calling data analytics. We have what we call data science, which is a multidisciplinary field that aims to produce broader insights. So each of these technologies complements one another, yet can be used as separate entities. For instance, big data can be used to store large set of data, and data analytics techniques can extract information for simpler data sets. So the two of them, they go hand in hand. We store large complex data, we extract it using data analytics, then we can be able now to have meaningful interpretation for decision making. Then we now deal with big data. And when you look at big data, as the name suggests, big data simply refers to extremely large data set. This size, combined with the complexity and evolving nature of these data sets, has enabled them to surpass the capability of traditional data management tools. This way, data warehouses and data lakes have emerged as the go-to solution to handle big data, for surpassing the power of traditional databases. So these are data that are so large, very complex, that now they cannot be stored in traditional databases. They need now to be warehoused in a data warehouse or data lakes because of their size and their complexity. Just a minute. And some data sets that can consider truly big include the stock market data. You can imagine like the Nairobi Stock Exchange, all the data for traders that are trading in that particular market, so that is type. Then we have social media data, sporting events and games, especially for the ones that are doing gaming, betting. So that is a lot of data that is being stored on all the games, and scientific research and research data. All this will form part of big data that needs to be stored and needs to be analyzed when we extract this particular data. Then we have what you call so this chart shows what we call the 5 V's. The 5 V's of data. The 5 V's of big data. 5 V's. We normally have the value, the veracity, variety, velocity, and volume. So these are the 5 V's of big data. Just remember, we have the value, veracity, variety, velocity, and volume. So we look them into detail, which forms part of the characteristics of big data. So when we talk about the volume, big data is enormous, for surpassing the capability of normal data storage and processing method. The volume of data determines if it can be categorized as big data. So we are looking at the volume of that particular data. Is it so complex? Is it so large? So that now we can term it as big data, because when you're classifying data, it's either big or small data, and therefore volume is key. And the second one is variety. Large data sets are not limited to a single kind of data. Instead, they consist of various kinds of data. So big data consists of different kinds of data, from tabular databases to images and audio data, regardless of data structure. So it has variety of data in one. It can include image, it can include video, it can include files, all those variety of data that can be included in one particular data. That's why it will form part of characteristics of big data. So variety, not just one particular kind of data, not only the text, it can include video, it can include audio. That's why we are calling it variety. The third characteristic is velocity. Yeah, velocity is the speed at which data is generated. In big data. New data is constantly generated and added to the data sets frequently. This is highly prevalent when dealing with continuous evolving data such as social media, Internet of Things devices, and monitoring devices. So velocity, the speed at which the data is added into the database. That particular speed, because when you look at even gaming, the games are added almost each and every day. When you look at social media, people are uploading each and every day. People are posting each and every day, and therefore the speed is high. Assuming you have 1 million users of social media and each and every person posts within a minute, the velocity, the speed in which the data is being generated, and that one forms part of another characteristic. Then we look at veracity or variability, and this says there will be inevitable be some inconsistency in data sets due to the enormity and complexity of big data. Therefore, you must account for variability to properly manage and process big data. So variability, the way the data will vary. Now, because the data is too much, then by the end of the day when you're analyzing, there may be enormity or some degrees of error that may be performed, and because of the complexity of the data. So we're looking at the veracity. What particular degree can we allow whenever we are managing this particular data? At what particular percentage do we allow the data to vary from one point to another? That is veracity. And the last one is value. The usefulness of big data assets. The worthiness of the output of big data analysis can be subjective and is evaluated based on unique business objectives. So we are looking at that particular data. What is the value of that data to the organization? And that one now we are saying it will depend on the objective of the organization. What are the key objectives? What does the organization need to use that data for? And that one now is where they will value that particular data. They will put value on the data, so that if they lose that particular data, what could be the effect? If that data is lost and is in the hands of the wrong people, what could be the impact to the organization? And that's why we are talking about the usefulness of big data assets. So the worthiness of the output that we are looking at, it is subjected according to the organization. So those are the 5 V's of big data: the volume, the variety, velocity, veracity or variability, and the value. So the next area, we look at the types now, the types of big data. Types of big data. The first one is structured data. Any data set that adheres to a specific structure can be called structured data. These structured data sets can be processed relatively easily compared to other data types, as users can exactly identify the structure of the data. A good example of structured data will be a distributed RDBMS, that is the database management system, which contains data in organized table structure. So when you talk about structured data, these are data that already has been structured, either into tables or either into tables. And when you're analyzing this data, it becomes easy because already it is structured compared to unstructured or semi-structured. So this one already has been defined, whether it is table, whether it is what, those particular variables have already been exactly identified, and the structures already have been put in place under the structured data. But when you look at the semi-structured data, this type of data does not adhere to a specific structure, yet retains some kind of observable structure, such as grouping or an organized hierarchy. Some example of semi-structured data will be markup languages, XML, web pages, emails, etc. So partly they are structured, partly they are unstructured, and that's why we are calling them semi-structured. And the third one is unstructured data. This type of data consists of data that does not adhere to a scheme or a preset structure. It is the most common type of data when dealing with big data. Things like text, pictures, videos, and audio come up with under this particular data. So it's not structured, it's not analyzed yet. It is just put the way the raw data, which is yet to be analyzed into table, into Word, and that's why we are calling them unstructured data. When we talk about the text, the pictures, the videos, it is according or up to you now to analyze and now structure that particular data in order for you to get meaningful observation or interpretation on it. The next thing, here now it gives us the difference between the structured data and unstructured data. And when you look at the structured data, it is difficult to collect. Yeah, structured, because this one already we need people that have already analyzed that particular data. Then affordable to collect, process, affordable to collect and process, another advantage. So it's affordable because already it has been analyzed. Yeah, it is data that has already been fine-tuned to what you need. Then it has limited insights because already it will depend with the knowledge and the objective of the person who collected the data. So the data will be presented according to the person who collected it. That's why you cannot be able now to have all the insights that you need. Then purpose driven, it is only useful for the purpose that you really require that particular data. Then it requires active participation, yeah, so that you can ask people questions, so that you can get the real interpretation, what they really intended to do. Then transparency promotes privacy. Yeah, so whenever there is a transparency, because already the data is published, some of the data structured already is published, then you can get it can promote privacy in some instances. When look at unstructured, it is easy to collect because this is raw data. Yeah, you can easily collect it. Then pricier to collect and process, so it is costly to collect this data, simply because it is you now to go to the field and start collecting that particular data, because it is yet to be collected, yeah, compared to this one. So is it pricier? Nearly infinite insights, you can get a lot of insights because it is upon you now to know and determine what you really need to interpret from that particular data. The data is reusable, you can really use it many times, yeah, from one area and the next area, to draw conclusion, to draw word, to extract anything yeah, that you need to extract from that. So the data will be reusable, unlike this one. And it requires presence only, so you need to be there in order to collect this particular data. And you have lack of transparency and lack of privacy, because you need to follow people so that people can be able to give you the data that you need. Yeah, lack of transparency, people may hide information. Maybe when you require that particular information, people may not be ready maybe to give you, depending on the policies of the company, or depending with the nature of the individual. Some individual even required to be paid in order for them to provide the information. So there will be lack of transparency in the way the information will be shared from the source, yeah, from the source people, the people that are giving us that particular information. Then we look now at data analytics. That was a big data. So data analytics, yeah, data analytics is the process of analyzing data in order to extract meaningful data from given data set. That one already we have looked at it. Yeah, these analytics techniques and methods are carried out on big data in most cases, though they certainly can be applied to any data set. The primary goal of data analytics is to help individuals or organizations to make informed decisions based on patterns, behavior, trends, preferences, or any type of meaningful data extracted from a collection of data. For example, business can use data analytics to identify their customer preference, purchase habits, market trends, and then create strategies to address them and handle evolving market conditions in a scientific sense. A medical research organization can collect data from medical trials and evaluate the effectiveness of drug or treatment accurately by analyzing those research data. So that's the main importance of data analytics, that we are trying to extract meaningful observation and interpretation so that it can be applied into the business. Yeah, if you need to know, like whenever you're doing segment marketing, you need to know the nature of your customers that you're dealing with. You need to know the trends, what are currently, or what is currently in the market, what are customers currently in need of, so that now you can measure on that. You can look at the purchase habits, you can look at the cost, you can be able to monitor all those variables, and by the end of the day you will be making a good decision regarding your business using the data that has been collected, and now you analyzing that particular data. That is what the main primary goal of data analytics, in order to assist individuals and businesses to make informed decision. Then look at the types of analytics that can be carried out. While there are multiple analytics methods and techniques for data analytics, there are 4 types that apply to any data set. There are 4 of them. The first one is descriptive. This refers to understanding what happened in the data set As a starting point in any analytical process, the descriptive analysis will help users understand what has happened in the past. So it is describing, from the word descriptive, it is describing the process, what has happened in the past, the process of collecting data, the businesses it has been performing in the past. Before now we start projecting the future, we first explain what has been happening. Here we are looking at the past so that you can use that past information in order to predict what can happen in the future. Yeah, that is just descriptive, describing and analyzing the process. Yeah, from the start to the point that we are now at, we analyze and be able to know what has been the process, what has been happening, what has been going on. That is descriptive. Number 2 is diagnostic. And for the diagnostic, the next step of descriptive is diagnostic, which will consider the descriptive analysis and build on top of it to understand why something happened. It allows users to gain knowledge on the exact information of root causes of past events, pattern, etc. If you're looking at a business situation, maybe you have been making losses, or maybe you have been making profit. You have been a trajectory profit making. Yeah, the curve has been trajectory improving. So we can look at that particular process and now diagnose what are the key factors that have led the business to be making profits, or what are the key factors that have been making the business to incur losses. So we diagnose that particular process and come up to a conclusion, yeah, on the areas that maybe we need to work on. So diagnostic, like when you look at the medical field, they look at the root cause of a disease or root cause of a problem, so that now they can measure on that particular root cause and be able now to heal. Yeah, if the starting process, or if they need to do an operation, they will first do a diagnostic process. The next one now is predictive, whereby now predictive is looking at the future now. As the name suggests, predictive analytics will predict what will happen in the future. This will combine data from descriptive and diagnostic analysis and use ML and AI, artificial intelligence techniques, to predict future trends, pattern, problem, etc. So this is another type of analytics, now predictive. Remember, we have started by looking at the past. We have analyzed the events that happened in the past. We have gone specifically to the root cause of some specific events, that is diagnostic, and now through that we have learned that in the future you can be able to protect this, or you can be able to prevent this particular problem, or you can be able to improve by doing these and these. So by doing that, now we are predicting the events that can happen in the future and the possible solutions that you can be able to offer in the future through predictive approach. The other one now is prescriptive. Prescriptive analytics takes predictions from predictive analysis and takes it a step further by exploring how the predictions will happen. This can be considered the most important type of analytics, as it allows users to understand future events and tailor strategies to handle any predictions effectively. So prescriptive is like the medical, the way they prescribe, yeah, the type of the medicine that you'll be able to use in order to cure a certain disease. So we are prescribing. Remember, now prescription comes from predictive. We have predicted this will happen, and now we can prescribe the solutions to that particular problem. We can now be able to have accurate prediction. Like when you look at those people that bet, they normally analyze the past games, the way teams have been playing in the past, the way now we are expecting if that pattern will happen in the future when the teams meet, and now we can be able to have a prediction of what will happen in the future. And that's why now you'll find that there are even people that come up with the odds. The odds comes in because of the prescriptive, that this team has higher odds of maybe winning over this other team. So they can be able to predict. Some of them they can predict with certainty, because when they look at the whole process from the past, they have diagnosed the problem, they have predicted, now they can be able to prescribe with certainty what will be able to happen. And that is under the prescriptive stage. We are taking it to another step. After predicting analysis, now we can be able to explore with certainty what will happen in the future. So those are the four major types of analytics that can happen. You can have the descriptive, you can have the diagnostic, you can have the predictive, and you can have the prescriptive. Then the next thing, we look at the accuracy of data analytics. The most important thing to remember is that the accuracy of analytics is based on the underlying data set. If there are inconsistency or errors in the data set, it will result in inefficiencies or outright incorrect analysis. We are looking at the process when we are collecting, because the accuracy of the data that we are using will start from the source. How did we collect this particular data? Yeah, the people that collected the data, were they qualified personnel that knew the data that we needed, yeah, or the data that was required? If there was error from the start, if there was any inconsistency at the start, then the data set that we shall be using to do analysis, it will be a wrong data, and by the end of the day we may end up giving wrong analysis because the data itself was not good. Therefore, we need to set ground rules from the word go when we are collecting this data, so that the people that are collecting the data should be qualified enough. They should know the type of data, they should follow the laid down rules that they are supposed to follow, and they should do it in a consistent way so that we may end up collecting the correct data. Any good analytical method will consider external factors like data purity. Yeah, we are looking at bias. The people that were collecting, were they biased, and any variance that may arise in that particular data. In the analytical method, we have what we call the normalization. Purifying and transforming raw data can significantly help in this particular aspect. So normalization is whereby if there was any error, we are able now to normalize in order now to have a data that actually is following a certain normal curve. We purify. If there was any error, we can purify by removing those particular errors, and we can transform now that data into something that can be of significantly importance. Then we have the data analytical tools and technologies. They are both open source and commercial product for data analytics. They will range from simple analytical tools like Microsoft Excel Analytical Pack. This is what currently we are using, the Microsoft Excel, and this one comes with Office. Then we have the Business Object Suite and open source like Apache or Spark. So these are other tools that can be applied. When considering cloud providers, we have Azure is known as the best platform for data analytical needs. It provides a complete tool set to cater to any need with its Azure Synapse analytical tool, Apache Spark based, Databricks, HDI Insights, you have machine learning, etc. All these are tools that can be used for data analyticals. And then we have AWS. All these are tools. And additionally, we have specialized BI. We have what we call Power BI, for preparing the dashboard. This is another powerful tool apart from the Excel. Power BI comes in hand for preparing those complex dashboard. Power BI can come in hand, and they provide powerful analytical function with relatively simpler configuration. Example include Microsoft Power BI. You have SAS, Business Intelligence, and Periscope data. Even programming language like Python and R can be used to create custom analytical scripts and visualization for more targeted and advanced analytical needs. So they can be applied. The Python, whereby people now can come up with a program language that can be used to analyze the data. So these are some of the data. Some of them are so advanced but still a part of data analytical tools that can be applied. And that is the end of this particular lesson where we have been looking at the big data and data analysis. Big data and data analysis. We have looked at the 5 V's. Let me just go through what we have covered. We have looked at what is big data. Under that, we have defined the data. We have looked at what is big data, the 5 V's of big data: the value, veracity, variety, velocity, and volume. We have explained them. We have looked at the types of big data, where there are 4: structured. There are 3: structured, semi-structured, and unstructured. We have looked at the differences between the two, structured and unstructured, and we have looked at what is data analytics. We have looked at the types of analytics, where there are 4. You can either have descriptive, diagnostic, predictive, and prescriptive. And we have looked at the accuracy of data analytics, and we have looked at the data analytics tools that can be applied. So continue subscribing, and I will attach the full notes on this particular theoretical in this particular lesson, so that you can be able to read at your own. So continue preparing for the exams by reading, because business data analysis, we have 40% which is theoretical, and 60% which is for calculations, and you must be well prepared in both aspects because they will come in hand in enhancing your pass rate. Thank you.